Okay, so first of all, I've got a few things going on here. I'm just trying to get a setup so I can explain this. But this is the relay that we are going to be looking at today, and this this actually came straight out of a Harley Davidson. So very good representation of a automotive or vehicle application. This is primarily for 12 volts on the coil and the contact. So there are different types of relays, and some of them, the coil can operate at 5 volts, 12 volts, different DC voltages on the coil, and then you could put either DC or AC across the contact. So each relay has a coil and a contact, and you can actually see that represented here, where I think it's 85 and 86 terminal are the coil, and then the contact goes from 30 to 87 or 87A. So 87A is normally closed. It's a closed circuit all the way around, and 87 is normally open. So when that coil pulls in, it's going to close the contact. So we'll get more into that. I am going to open this up so you can see what is inside and then how it operates. Hey gang, if you like this content, please don't forget to like and subscribe. Okay, so again, here's our relay, and I just love taking stuff apart. I've done it since I've been a kid, and luckily I still have all my fingers. So let's see if we can get this thing open and see what's inside. All right, looks like there's just a couple of tabs on here, and sure enough, we can just open that guy up, and that's just a cover. Again, it's got the circuit diagram on there, and inside this relay you can see that we have a coil that's wound around a spool or something like that, or maybe an iron core, and then when the coil, so these are the leads for the coil, and when that coil is energized, it turns into an electromagnet. And what's happening there is once it's energized, it will pull in this contact, and we can actually demonstrate that. But so again, this is the coil and this is the contact side, and you can see that there's some very heavy wire on there, and then there's probably some special materials on that contact. I forget what type of materials are used, but it's for high current. And that's really the purpose of a relay, is to, kind of isolate and control high current situations. So it doesn't take much current to pull in the coil, or very big wires. I mean, you can use very thin wires on the coil side, but if you have something that takes high current, like this halogen bulb, I think this takes about 3 or 4 amps, you probably want to have some larger wire to handle that and put that heavy current across the contact side. So let me get this connected up here, and we can demonstrate this relay and the electromagnet. Okay, so what's happening here is I've got my battery connected. This is the positive side, this is the negative, and it is a 12 volt battery. And basically I've got my positive wire running through a switch and to one side of the coil on the relay, and then the negative side is coming around to the other side of the coil. And so here we can see, and I'm going to get a close-up, but I do not have the switch on. but when I press the switch, you can see that the contact is moving in and out. And it doesn't take a lot of current to pull in that contact. So that is the advantage of the relay, where you could use a smaller switch to turn the relay on, and then on the for the coil, and then on the contact side you can put a very high current item on there, such as a halogen bulb, or you know, anything that pulls a lot of current, like a winch or something like that. So anyway, here we just see that we're pulling in the coil. Okay, so next step is to connect the contact side. All right, so I've got this thing off right now, and basically I have to get that power, that same power, across the bulb. So I am going to take one side of the contact here, and connect it to, I guess we'll call that the positive side of the bulb. And then I am going to take the other side and hook it to the negative side of my battery, and then hook that to the negative terminal on the bulb. Now you can see nothing, the bulb did not turn on, and it's not going to turn on until I turn that switch on and pull in the coil on the relay. So by pulling in the coil, I'm closing the contact and allowing the high current to run across the contact side of the relay. So in a sense, we are isolating a very low current situation here from a high current situation. And again, in an automotive application, you are going to want to make sure you've got the appropriate size wires to handle the current, because if you have, you know, super tiny wimpy wires on something that's trying to pull, you know, 5 amps, 10 amps, something like that, you're going to smoke your wires for sure. But anyway, this is just a slick way to do this. I would typically have a fuse in the circuit as well, and that way, if anything is a short circuit, either on the light bulb side, you know, you'd have a fuse in there with the appropriate current rating to handle the current needed to energize the bulb. And then on the coil side, you would have a very low current fuse, you know, maybe 1 amp or half amp or something like that. So anyway, that is in summary the way that a relay operates, and very simple. It's just a electromagnetic coil pulling in a contact. Okay, thanks for watching. If you have any comments, please leave them in the comments section, and like and subscribe.